Go ahead.
All right, so I'm Dave Finnegan from BAE Systems. I have a question, and I can only remember the last speaker, so I apologize to everybody else. A little confusion between the digital twin and the digital shadow. It seemed like they're the same thing. So if you could clarify that, I'd appreciate it.
Yeah. Yeah. Okay, sorry about that. So that was I completely agree with you. Digital twin, digital shadow, they're part of the same definition. So that was the idea of the slide I gave for the definition. It talks about the digital twin being a representation, a digital representation of the thing that's being developed. That thing can be as engineering, it can be as the data that comes back from production, or it can be the digital thread that's created throughout the life cycle. Does that help? They are the same thing. That was what was captured in the definition, but it's about people use the term digital thread as separated from the digital twin, but to my mind, they are all the same thing, but it's just different subtypes of it. Okay.
So if you were at AIAA ITech a couple weeks ago in Orlando, Florida, we had a 4-hour panel session on digital twin, and it was almost came to blows because people are very opinionated on what digital twin is. We had a great definition that it was a beautiful way to do it. We did literally data mining search of the internet on digital twin, and we looked for what words appeared the most often, and then we stitched it back together. And when we did it, it's like, well, that's almost Boeing's definition, so I'm okay with it. Other folks didn't like it. So we had this long definition. What we ended with was somebody said, we need an Oxford English super short definition, then we can kind of tailor it for our. So that super short definition is a digital twin is a virtual representation of a physical asset, period. Everybody can get behind that. The big question is, can a digital twin exist before a physical asset is built? Boeing says no, the government says no, because they say it's an as-built physical asset. But other folks, like Graham, know it can exist at the beginning. We call that a digital system model. We call what he calls a digital shadow a digital twin. Once you've built it and you're collecting data from something you've built, in Boeing vernacular, that's the digital twin. But once again, we all understand what it is and we understand the value of it. But across industry, we're calling it different things. Some people, Dr. Michael Greaves, who kind of coined the term digital twin, he calls the early version before you built something, he calls that a digital twin prototype. Once you've built something by tail number, he calls that a digital twin instance by serial number. If you built 1,000 of them, you've got 1,000 digital twin instances. The aggregate of all those for a product type, like a 737-8, that's a digital twin aggregate. It behaves the way that class of product behaves. But once again, some people have different definitions, but the simplest definition is a virtual representation of a physical asset for digital twin.
Just as an added thing, yeah, it also depends upon what domain the tool is in. So the CAD people think the digital twin is the 3D CAD representation. The systems engineering people think it's the virtual prototype. The PLM people think it's the BOM. Okay, there's different people think about, and to some extent it's domain dependent as well, but they're all talking about the same thing effectively. And being able to integrate the information together, that's the key, really.
Okay. Go ahead.
Good afternoon. Steve Untz from BAE Systems as well. But
Nice.
on the diamond model.
There's too many BAE people in here. Okay, you've already used your
there's
quota,
three
okay?
of us, actually.
Go ahead, sorry.
On the diamond model, I first saw that, I think, in 2018.
Yes.
And I'm curious if there's anything that has evolved, changed, or been learned and applied since then.
There has, I was just mentioning this. We first unveiled that model in 2018, April of 2018, at the National Institute of Standard and Technology MBE Summit 2018. I literally almost got booted off the stage. The moderator jumped up on stage and grabbed the mic out of my phone, out of my hand, and had to interject his own comments, which I've never had before as a speaker. He's a huge system engineering V stalwart, and he thought I was calling his baby ugly because his baby wasn't good going forward to the future. I mean, literally, the moderator jumped up and grabbed the microphone from me. So we've worked on the messaging since there to show that the diamond is built upon the V, not that the V was ugly and it doesn't do its job. But since then, the major refinement has been that the early versions of the V, actually, instead of virtual at the top, it said digital twin. That caused confusion because some people read that the entire top was the digital twin. Other people said, no, I kind of meant it as once you turn the V and you started building something, when you turn at the top and you're modeling that thing that you built, that's the digital twin. But to clear that up, we just called it the virtual because everybody can agree everything on the top is virtual. So that's really the only major change at the simple level of it. The detailed level, the little bullets around it, we continue to refine those. As if folks adopt this, you're going to take those 12 milestones around there and adopt it for use. You're going to use your own terminology. So the detailed version's undergone a lot of change. The super simple version really hasn't changed for the past 2 years. I will mention now, that diamond has been adopted in various engineering organizations within Lockheed, within Northrop, General Electric, Rolls-Royce, Aerojet, and Procter & Gamble, among others. So it does resonate with a lot of people, which is great because we really want this industry to start adopting something like that as the new way going forward that looks different. Thanks for the question.
Hi, my name's Eric Savoy. I work at Boeing. I have not met you personally, Dan. So I'm a product owner for one of our MBSE teams working on a project.
Sound like a disclaimer.
Yeah,
Yeah.
it is. It is. So, Dan, you mentioned the model versus the document. And Kevin, you did kind of like a World Wrestling Federation throwdown that documents are here to stay. I don't think Dan would oppose that statement, but it seems like after I thought about it for a couple seconds, you're actually agreeing with him that two different groups went to the model to receive a document.
Right.
So what I would suspect, and I'm fairly young to systems engineering, but that documents will increasingly complement models as time goes on. So my question is for all of you, do you have any revelations that have come about with your own organizations and companies in this theme of documents being a part of the model? Could be a warning sign of when a document incorporation didn't work, or thoughts as to when is the right time to consider. And Boeing is a group of, we're a federation of systems. We're not going to have a single model to rule them all. So we're already in place aware that we have to play with a lot of different tools and a lot of different places for information source authority.
So let me see if I can boil that down. You're wondering any truly successful document conversions to models?
Or failures that we could learn from.
Okay. I think the first, you guys can comment about whether it's even possible or not, but one of the things I would note is, do you even trust the existing document as being a source worth saving? So go ahead, I'll let you make your comments here.
I don't know where to go with it, really. I mean, from our experience, we take documents and use it as a starting point to produce our models, and then work with the client in the modeling space sometimes. So, and that seems to be very successful. But I think also your question was sort of other end as well, wasn't it? Producing documents from models. Was that right as well?
Well, we know to take a PowerPoint file or Visio and slap it into SysML is not our end goal, right? And I've seen pressures from internally to, hey, let's get that, and we know better. When we make connections that don't exist within some Visio model and we're able to synergize, groups, individuals, organizations will start to see benefits. So what I'm looking for are spotlights of when it became apparent that it was working, and could you isolate what really made the difference that it was going to work, versus let's check the box of doing something and then we're moving on, and it gets forgotten, because that's clearly what we're not about, in it for the long run.
Go on.
Yeah, so one of the companies that I work with, I've been working with them for a very long time, but their chief engineer got the power of systems engineering when they had a project that got stalled, and they couldn't work out their requirements, okay? It was just getting stuck. So they gave this bunch of documents to a team of 3 that were using MBSE techniques. They weren't even using the complete bunch of techniques that we can use in MBSE. I think it was in 2 days, so that's 6 man days, they found about 150 issues that had not been picked up by the people that were using the documents, because they weren't, okay, when I think about the model is your memory, okay? You cannot understand all the interactions that you have within a physical document in your head. You can't keep them constant. So the model becomes your memory, it becomes your context, and you start to understand the inconsistencies. And this was just using sequence diagrams. This is not an advanced technique, but they found 150 issues in 2 days. And that was the key moment that you were talking about, that this company's chief engineer picked up on and said, we've got to do this.
So what do they do, Graham? They just went through and manually parsed it into sequence diagrams?
That was just doing it manually.
How's that? And just
Yeah.
by doing that, they're able to identify the inconsistencies?
Yeah, yeah.
Okay.
So they found issues, interface issues, they found data issues, they found messaging issues. Okay? And there's a few other stories, but I'm not going to take time from you.
Okay.
I want to answer this one too, because as the representative of the non-engineering here, even though I've been a lifelong engineer myself, there was one of the key things that that has resonated with me is that the models are the representation of the knowledge, right? And as you kind of touched on, and then I think this was your point about Kevin about don't lose the documents resonated with me, because we work with a lot of non-engineers, and as a body in COSI, we're all systems engineers here. We're used to it. We want the rigor, but we can't lose sight of the fact that if we're going to turn these things into action, we have to be able to communicate these ideas to other people, and we can't force them to say, you have to speak my language, we have to speak theirs. So I think that's very critical, and I think David Long says it. He says we have to meet people where they're at and then take them where we want them to go. So, and I think that's where using the format that other people are used to. Granted, like you saw that curve that we had. It's not just about new technologies. It's about new ways of thinking. Yes, we want to move away from PowerPoint. Yes, we want to move away from Excel because there's a lack of structure that comes that you get that structure when you add the semantics of a modeling language. We definitely want those things, but we can't lose sight of the fact that it's a small minority of these organizations that are actually the system engineers.
We've got to be able to present the information in the way that the business users want to see it. That's one of the key things that we've learned within IBM, and we've seen it with customers all over the place. People don't like rectangles with corners on them. They like oblongs, and they want to lay things over things, and they have some weird stuff going on. Yeah.
So
You saw a
Ryan,
number-
let me add one comment here.
Yeah, go ahead.
Ryan, when you talked about this idea of using the models during reviews, that was in your commentary that you made as far as integrating the models with your product lifecycle, right?
Right.
So I've been in these meetings where they use models for reviews, and half the meeting was chewed up by explaining the language that they're looking at. So what have you done to solve that problem, or what have you done to improve it, or whatever? I guess that's what kind of triggered this.
So one of the things we're trying to do is educate and train people so that they know what to look for, and it's a very different kind of environment doing a review, going through models than you would want to do using documents, because you can take advantage of a lot of the features that modeling tools have to be able to interrogate the data and display the results in a way that's much easier to absorb. But one of the challenges that I've noted is that a lot of times we give people a bunch of documents and we just assume, we don't give them any training at all in terms of how to interpret them. And the problem with that is a lot of these documents were written by multiple people, and even the figures in the document were produced by different people, different assumptions, and they're not consistent or compatible between them. So we gloss over the fact that we really need to train people to read each of these documents, but we just assume, oh, it's boxes and lines, it's words, engineers can figure it out. The reality is they can't, but we don't realize that until we start to model it, or at least review those documents with the intent of modeling it. And I'll echo what Graham said. That's one of the things that we found a lot as well. A lot of times when we're tasked to initiate a project, a modeling project, with the intent of architecting a 2B, we have to model the as-is as a point of departure. And so we look at the existing documentation and use that to try to develop these models. And that's where we find a huge amount of inconsistencies, ambiguities, and so forth that no one ever found before. And we're not really using the model necessarily to find that. It's the act.
exploration.
Exactly. It's the act of modeling that ferrets a lot of these out, and we need to get the SMEs to figure out and agree on what the truth is before we can actually start modeling it in earnest.
So from that perspective, it's worth the exercise, whether it's bad or untrustworthy documentation or otherwise, to go through this exercise to get to an understanding of what's going on as we go forward.
Absolutely.
Definitely.
Okay? So that's part of your justification, if you will, to move forward here, was we don't propagate these problems that are carrying with us, right? I'm sorry, Danny,
Absolutely.
I interrupted you. Were you going to say something about?
Yeah, there's another point you made about the training for the reviews. So this company that I was talking about earlier on, and it goes back to how do you implement model-based systems engineering within a company. They got really, well, they are very serious about it. They developed a structured set of training courses. And the lowest level was basically a reader course. It's like, how do I read a basic SysML model using our DSL or the process that we've got? Okay, and that is the first thing that you need to do to be able to spread it across the organization. Okay, the next layer up was sort of like a user level, so that they could create models, and the next level up was a project leader that could actually roll out the tool, roll it out to a project and help and guide a project through the process of actually developing a set of models for their specific projects,
Okay.
products.
Anything else to add? No. I know we could talk throughout this issue. Go ahead. Who's next?
Yep. Good afternoon. Alfredo Patag with Procter & Gamble. So we're in the state now where we have taken the documents, our traditional documents. We put it in Rhapsody as a base. I'd like to understand if you have any tips on how to effectively conduct subject matter expert interviews such that we don't lose them, right? I mean, so what I've done, and so I'll tell you what I've done. I printed out, plotted out PDFs of views of the model, sent that out as pre-reading, and then I get together 2 or 3 subject matter experts at a time for about an hour, 2 hours max, because I mean, we're really tapped out after that, right? So wanted to get your perspective on that. And then also the notion of, would it be effective? I mean, my view is, as a technical readiness leader, partnering up with a program manager to use model-based systems engineering to guide the holistic learning plan is what we're calling it in our company.
Question.
So it's 2 parts, so
All right,
I'll
that's
leave
what
it at that.
P&G does to us all the time.
Sorry.
So, hold on, step up there, come back up for just a second. We need, so you're looking for, first part is you're looking for advice on how to extract or validate models with subject matter experts. I think it might be helpful to them for you to describe what a subject matter expert in your world is. He's an expert on a function, or a transition, or a transformation.
It's multiple layers, right?
So pick one.
Yeah,
and
so
pick
let's
one
say expert on transformation. So we've got fundamental transformations in our to produce our different product lines, and our thought is, we would focus on one transformation at a time as we're building our up to the end product and focus on that.
So, and a transformation might be remove water, something like that?
That could be a transformation,
transformation.
or fold this
You
material.
might think
or
about it as a
whatever.
function maybe, but, so they got experts on the removing of water from things. And these experts are among the few in the world, right? Kind of people that know everything there is to know about dehydrating stuff, okay? And so what he's asking for, what's a good way to extract information so these guys into some kind of model or otherwise that could be used to replace, if you will, or stand in for some of these experts, okay?
So I've been working with Bob Sherman at Procter & Gamble for the past 5 years on exactly that problem. We call it knowledge-based system engineering. How do you capture that subject matter expert knowledge, which is in their head, into the model? Mark, in your presentation you showed, I call it the half-life of knowledge, right? In the aerospace, it's about 15 years before we forget things. In the automotive, it's about 3 years before you forget things. I would say in the consumer product goods, it's even quicker than that because you're introducing new products all the time.
Correct.
And the expert in that knows how much zinc you can put in toothpaste, he retired.
And so we're going to learn that lesson all over again. So how do you capture that knowledge from that person in a model that if somebody wants to try a new formulation, you get a flag that pops up and goes, oh, that's not going to work because the consumer is not going to like the way it feels in their mouth. So that's really all about, and so it's a shame that Bob Sherman's up in his, up in his room sick today, because you would have seen that presentation on exactly what we're,
I'm sorry.
what we're trying to do there. And
Well, you can rag on Bob for us and tell us how disappointed we are in him.
but it really is that. And so I like the term knowledge-based system engineering, because you want to capture that subject matter expert knowledge inside the model. And you know, we all know you use model-based system engineering to do change impact assessment. So you've got a huge corporate model of all the touch points. But if you want to make a change, it'll quickly highlight you need to talk to these experts. One, it flagged it because it looks like that might be a problem with that, but you don't have to talk to, you don't have to have every expert in your company sign off on every change, right? You know who exactly to go to because this is going to impact them and they're the expert in it. So that's really what it's all about, is trying to capture that knowledge inside of models.
And you would say the first step of this process is to map who it is out there that you got to talk to so you understand the impact, be one step in the right direction.
Who your domain experts are, your subject
So you have that mapped so you know who to go talk to about. So that's one step, okay?
So, yeah, so I would add, you know, from my perspective, we've done similar things to you're talking about, engaging them and sending them out pre-reading material. But, you know, we talked about it, or Devon just talked about it in terms of talking their language, go to where they are and understand how they're addressing this problem and work with them on that. And so don't show them a SysML model because they haven't had time to learn what a SysML model is, but put it into a language that they can understand and then start to take them on that journey to understanding the model more and integrating that knowledge. And what we've found is with the subject matter experts, when they actually start to get it, they start to get invested in the design and are willing to contribute more to it of whatever the thing is you're designing. So yeah, I would encourage you to think about their language and iterate a couple of times, you'll get more out of them.
Yeah, and
Yeah, the white, yeah.
I was just going to say we did have that experience where we've drawn in the subject matter experts. Then they see the value that they're pouring out their knowledge into this total picture, and they see it, right? So
and they get ownership of it.
Yes,
it's their information.
absolutely.
It's not yours. It's their information.
Exactly.
They can see it, and they really feel empowered by that.
Right.
So yeah, so piling on to the previous responses, I think what we're really talking, I mean, we're not arguing about that. There is a need to separate the knowledge from the person, right? And I think what we're talking about is what are the best tactics. And I think one of the things that we have entire systems of how to engage with like stakeholders and SMEs. And one of the things that we always try to do is is make it narrative. Right, when people can actually connect with it and the way it's going to affect them, not necessarily just in terms of a technical principle, we want to talk about those too, but when we can actually talk about how it's going to affect the person, it resonates a whole lot more and it gets people to open up because you start thinking about which parts are critical and which parts are not.
Okay, that's part one. Part two.
One thing I wanted to add to that is the intent of this is not to replace people with models.
Agreed.
So it goes to what you showed of, Mark, in your presentation with the braking system thing. Who's impacted by this change and who should I go talk to? You showed it in yours for the MBSE squared of exactly what subject matter experts, if I make this change, I need to have these subject matter experts reevaluate this because it impacts them. So it's really about connecting you to the right subject matter experts. One, making informed decisions, better informed decisions, but it's not I never need to go talk to that physicist because I've got the model. That's not the intent. So we don't want to replace people with models. We want to make better decisions, but connect you to the right people that need to weigh in on your decision based on a proposed change you're making.
Yeah, and really our other goal is to give them freedom to practice even further beyond what they're doing today, right?
Correct,
That's our
absolutely.
goal.
If you have a question, step to the mic. Well, he's got part two.
There'll be ages walking.
I'm fine. You're good. No, we're good. Thank you.
Because if we're going to record this, then we want to know what the question is. You're fine.
No problem. You can. All right. So, Graham, you're prime, and now I'm going to get the fellow who worked at P&G like I
Okay,
did.
you're in trouble. Okay.
All right. So, Paul Sullivan, Northrop Grumman. So, Internet of Things allows us to be able to put sensors in situ and let us look at what we're doing with the model and give us back what's going on. But also there's a lot of data out there that we can look at from the way we've been making things, like when we're on a product line at P&G and we're making toilet paper and we're saying we're going to change the way we're going to make Charmin and we're going to weave it differently. And so And that's going to allow us to make it faster or make it with fewer fibers but still be cushiony. And so that information isn't located in the Internet of Things. It's located in a system called SAP, an ERP system. So between you two and the other people up there, the ARIS folks, who obviously are in this as well, tell me how we can leverage that logistical data to help us with that digital twins, to take information, succinctly said, so we can take information from something we've already done and model how it might work in something similar but a little bit different.
Okay. So, we're too close. Yeah. So I've also been doing a lot of stuff with Procter & Gamble over the past 2-3 years. And it goes back to the process that they're actually doing to capture their knowledge-based systems engineering. So they're doing exactly what you're talking about. They model things as functions and transitions. It's based upon the work that's being done with Bill Schindel in the patterns workshop. Okay? But it's taking a very much a separation of what you want to do to how it's implemented. And they build parametric models so that they can actually understand the interactions of all these different functions, whether it be the depth of the count of the weaves in the toilet paper as to how much it's going to absorb and do all sorts of things. But they're trying to build parametric models so that they can adjust that and then work their way through the analysis. Okay? They're also tying it into simulations. So they're doing simulations, and they're also using it to build the machines that build the toilet paper. They've really gone the whole hog on it.
So they're also, what Graham's talking about, they're also have a very complex system that's building a complex system, right? That's what the
Right,
P&G
so
guys are
for
telling you.
example, they use the same technology they use to build the toilet paper to make potato chips, crisps, Pringles. Yes, they do. So, and that's no trade
Well,
secret.
P&G guys are here, they can tell us whether
No,
it's true.
I know that. So, but I wanted to know, let's dive into the data they also get into the logistics system when they're actually manufacturing something that could maybe inform Watson to do some AI work and inform to us how we should run the machine differently. So we would program it differently, that our digital twin would be done differently.
I think it's a as-produced digital twin, so it's building up the information about the machine rather than the thing that you're producing. Okay, you've also got to monitor the thing that you're producing and make sure it's being produced right. But it's a case of having a model of the thing that's doing the producing rather than the thing that's being produced, as well as the thing that's being produced. And I think ultimately you end up modeling everything if you take it to that level, and it becomes bigger and bigger and bigger. You've got to find out exactly. I think it's something that we talked about earlier. It's about scope creep. What do you actually want to do? Where's the value for it? I know that P&G get value out of it at that level, and that's the sort of thing that they're doing. I don't think they've applied AI to it yet, but I think that's on their cards, and it's one of the things that we'll hopefully be talking with them about once Bob gets better anyway.
Yeah.
Okay.
Anybody else want to comment?
So the true value in the digital twin comes from connecting it across the life cycle. You have to connect PLM to your manufacturing operations management to your ERP to really get that benefit. If you're using it within one cycle, yeah, there's a benefit. You're just not getting the full benefit. And I actually don't think Pringles is part of the Procter & Gamble portfolio anymore, but it was 10 years ago. They came and briefed Boeing, and I was attending it as an R&D brief, and you're thinking, we're an aerospace company, what could there be similarity? Well, they were showing on the production side, they wanted to speed up
Making
the production of
composites.
Pringles, right?
And making composites.
What happened is the Pringles were, as they sped up the line, they became airfoils and they became airborne. They departed the conveyor belt and they flew onto the floor, and they're, well, okay, so we can't turn the machine up. What do we do? So they did CFD analysis on the Pringles. The solution was to turn the Pringles 90 degrees.
Yeah.
And then the increased speed just pushed it down onto the conveyor belt instead of lifting it up. It was a simple, but they had to do CFD analysis so they could predict how fast they could increase the. So it was using that digital model to see how fast it could drive. But we thought, when they showed the CFD of a Pringle, we were all on the floor rolling. It was hilarious.
Oh, so
Okay.
you're playing Formula One ground effects. You know,
Exactly.
That's right. Okay. All right.
Thank you.
Thank you. Out of questions? Is that what you guys are telling me? Go ahead, step to the mic, please. I mean, this is an august buddy here. You're not going to get them back together ever again.
Right.
Go ahead.
Well, first of all, thanks for the interesting presentations. I found that remark particularly humorous when you said avoid scope creep. In the 25 years I've worked on energy systems, turbine systems, engine systems, and more recently aircraft systems, we've never seen a project where, particularly in the context of customer-supplier relationship, where requirements did not change at runtime, or the change did not result in a significant scope change. So the question is, what does MBSE philosophy or the tools offer us in that domain, so that maybe the guidance is not avoiding it because it may be a fact of life. Maybe the guidance should be more about how do we use the MBSE philosophy and the tools to adapt to it or deal with it in a more cost-effective manner.
I've got a quick answer, but then Mr. Do's and Don'ts, since it was on his chart. But my thought is the rapid change impact assessment, because you can do I'm thinking about changing this requirement very quickly, like what Mark showed. You want to change the braking distance by 10 feet? It impacts these 6 systems. You go, oh, I thought that was going to be a no impact change. It just looked good in our sales brochure. No, it impacts all these systems. Never mind, I don't want to make that change. So by modeling it, you can do that very, very quick.
Okay.
My turn?
I'll just like 2 seconds. And then
Go on,
Yeah.
Graham.
I'll give you a bit more time to
No,
think.
I've got an answer.
So going back to the company that I was talking about earlier, it's one of the few places I've seen they did a side-by-side analysis of a development process for the same set of requirements for something doing a traditional requirements-driven approach against an MBSE approach. Okay. One of the things that came out of this was they looked at the analysis of the change requests. Okay. Mm-hmm. And it was really interesting. For one thing, they both had roughly about the same, I think the MBSE one had a higher number of change requests, but just a bit higher. But the real difference came down to exactly what you're saying. It was how quickly they dealt with them. Because they were done in about a third of the time as using a traditional, like a requirements change request process. And it was because exactly of what you're talking about. When you're doing models, you can quickly go through, you can test to see what you're doing, whether it's correct or not, whether there's any inconsistencies, and you can change it or you change the requirement, okay, depending upon what's doing. Especially at these early levels at the higher levels of systems engineering, where it's more abstract, okay, but where you've got the more formal change request process, it just kills the flow, basically. Sorry about that.
I've got the answer now, I think. Thank you for the challenge. Now, what I was really referring to was the purpose of the model. So in terms of using a model to derive or elicit requirements for a system, then you could increase the scope of those requirements, because that's the purpose of the model, is to derive the requirements. I guess the example I put in there was this particular client where we'd used model-based systems engineering to elicit user needs and the operational concepts and put that into the model. When they realized what we were doing and how powerful it was and the outcomes that coming to that, they started to think about other uses for that model. So how can we manage all our projects in one go? And so they're starting to add in other project models to it and increase the scope from a purpose perspective, not necessarily a list of requirements. So that's what I really meant. So there was a little bit of extra context there for you. Is that okay? Did that answer your question?
Yeah.
Okay.
To me, a good tenet of system engineering is fighting scope creep. And you heard Stefan talk about Agile. That's the key tenet of Agile as well. We'll consider all requirements, but we will lock them down for this sprint, and maybe the next sprint we'll pick up the new requirements, but they're locked down. We're accepting no new requirements, and the team is off for the next 3 months working to that set of requirements. So to me, that's just good system engineering to be able to fight off scope creep. Models can help you do it, but that's just good tenet of system engineering.
Okay, thanks.
Okay.
Thank you.
Yeah, so I think there are two different kinds of scope creep. You know, we talked about one, you know, the kind of scope creep that occurs because the environment's changing, your needs are changing. You know, you want to be agile and responsive to those changes, and MBSE can help you do that by looking at exploring those impacts early to help you to make the trade-off to decide whether or not that's worthwhile keeping. The other kind of scope creep, the one that we see a lot though, it results from the requirements or needs not being very clearly articulated. And so it's more along the lines of, oh, that's what you meant. Okay, well, that's something completely different than what I had already planned and budgeted for and was planning to execute. So to try to address that problem, what we're trying to do is be much more upfront and clear about what you're trying to develop, whether it's the real system or this MBSE system. You know, try to be very clear about that up front, but recognize that there is going to be evolution, there's going to be learning, and you need to be able to adapt to that, not only because everyone generally is learning about MBSE as we go along. Is not, you know, I don't think there's an organization out there that would say it's completely mature and steady state and it's not improving at all because we've kind of hit the pinnacle. So I think MBSE can help us to address both of those, but you need to develop a process that is agile and that has the discipline to be able to nail down what it is that your expectations are, at least for, you know, that first sprint, right? You want to make sure that you lock that down so you don't end up never completing that first sprint.
So Ryan, one of the complaints that people have against model-based, I guess, system engineering generally is they're old and slow, is kind of an attitude, if you will. But not everybody, of course, lives in that world. In the commercial world, what advice do you have for those that really don't know what the solution is at this point?
Well, one of the misnomers, I think, is that I think one of the challenges we face is that adding more systems engineering will typically increase the deterministic schedule that's required. You know, there's an upfront cost that you're taking on, right? The intent is to take that long tail of the distribution and tamp that down. That's the intent, right? To reduce rework, to reduce issues that come on that don't appear till later in the life cycle. So I think it is a little bit of a misnomer that, or a misinterpretation folks have, that a systems engineering is really a schedule killer, taking that long view. The problem is we incentivize program managers and other folks on the short-term view, and so they see that as an impediment.
Okay, so what advice would you have for somebody who's not sure what the customer wants? In other words, they don't get handed a set of requirements, right?
Well, that's typically the world we live in. So we help our customers, our government, agency partners to figure out what those requirements are. You know, one of the things we hate to do is come in. I would say coming in late in the process is coming in after the requirements have already been decided on, approved, and cast in stone. You're coming in way too late to really be able to make an influence. So what we do is we try to use these techniques, these system architecting and MBSE techniques, to help understand the trade-offs so that they can make the right choices as to what requirements make sense. And so we're trying to help them to do that.
So that would apply not only to your customers, but what about somebody like Apple or somebody like that?
Well, I mean, they have a little bit different problem, right? They need to try to figure out in advance what people want, right? And then build it in advance of having an RFP somewhere saying, this is exactly what I want to see.
So I understand about getting to the head of the RFP so you can make sure the right stuff shows up in the RFP to get what you want back eventually.
Right.
One of the problems, I guess, we got versus the federal, like if you will, and our highly regulated industries, I guess aerospace are in that situation. Energy is that situation where they have a set of requirements, regulations, and somebody puts out an RFP for a new whatever plant or a new airplane or whatever. But in the commercial world, they don't have the benefit of that, right? They have to go figure out what the customer wants and then see if it works or not, and they don't find out really until it works or until they have a smashed product, right?
Right. So there they actually have more flexibility and freedom potentially to explore those trades, right? Because now you have probably fewer constraints in some cases on what that system needs to do. It's more of a sliding scale. You know, the value that you bring and the costs that it bears and the revenue that you can bring, those are all parts of the equation that are tradable in that kind of environment. In the government space, it may be a little bit more constrained because you have so many stakeholders who feel that they have requirements to add to the fray, and so you end up having a much more constrained trade space there. We haven't done a whole lot in the commercial realm to understand really kind of what the drivers are, and there may be financial drivers, other things that we're just not as aware of.
Let's take a survey here. Who in this audience are highly regulated, government, federal, aerospace, energy, let me see, FDA, let me see, medical devices, those kinds of things, regulated? Okay, and who here are in the freewheeling commercial world? So I look at Roger. Roger works at John Deere, right, Roger? Do you deal with a lot of regulations? You got safety stuff like that, right?
We definitely have regulations.
Well, wait, don't you have regulations, though, from example, the Department of Safety, if you have to move a tractor across roads? So
Yeah,
that's basically it's the same as automotive, so he has the same regs, correct?
Well, automotive they're dealing with regulations and stuff like that, anything that travels on the roads. Yeah, there are
Yes, so he has to
some
do
regs, but what that combine does is up to them. It's not some farmer somewhere that says, hey, here's my RFP for my requirements, right, Roger? You guys got to go figure out what that farmer needs, and then you build something that will meet those needs. And if the farmer doesn't buy it, oh well, right? It's going to hurt Roger. That's a different perspective. All I've got to do in your world, because you guys got it easy, is I just have to fill the requirements that get handed to me. And I get paid based on the requirements. Did I meet the requirements or not, right?
Oh, I see you're stirring the pot, because
I am stirring the pot, because now Roger's got a different perspective on it, and Roger would tell you guys, well, that's all wood and good, but I don't get told all that kind of stuff that you guys get handed, right?
So just to add a bit to that, I mean, complementing what Ron was saying there, we do a lot of work with government agencies, and that's what effectively those agencies want to do. What they want to find out what the user needs are, so they can pass the requirements off to the industry. We've also worked on the other side of the contractual boundary, if you want, and particularly recently worked with a company, and they take a very similar approach that we do with the government, in as much as with government we take a scenario-based narrative analysis to try and elicit the user needs, then do a further set of refinement on those needs to understand what the system requirements are. They do a similar thing in that organisation. A small organisation produces small products, I won't say what they are, and what they do is they survey the market. They go out there and grab a bunch of light users, go to conferences with, trade shows with likely prototypes, and just test it with the individuals that are likely to buy it and do that scenario-based analysis. How would you use this? What do you want to get from this system? So we've seen that, and then they bring that back into their organisation and define the requirements from there. So a similar approach from my limited experience with one commercial company like that.
Okay, so you guys that raised your hands who are non-regulatory world, raise your hands again. Okay, so has this experience with the taint towards fulfilling a set of requirements that are handed to you or derived or otherwise helpful to you guys in the non-regulatory world? Step to the mic, please. We're taking an opportunity here to mind the crowd. Go ahead.
Right. So I actually work for John Deere, and
well, okay. There's two of you in the room at the same time. I picked the wrong one. Sorry. Keep going. Keep going.
But we really face this issue. Like, a tractor can be used in 50 different places, and different users use it differently.
Oh, so you're telling me farming in India is different than farming in Iowa?
Absolutely.
Okay.
And we need to think about different, and how do we evaluate or give importance to which uses we will try to support, and how do we support it over time? Because we do want to think about the next versions of our systems. We won't drastically change our systems.
So you guys are considering what areas of your product might need to change in the future, and you're considering that up front to make it easier to upgrade, et cetera, et cetera.
Et cetera, right. So we need to think about requirements as to what's basic, it's always going to be there, what varies across today, and what might change over time also. So really having to think about this. And then as we think about subsystems, like our engines go into tractors as well as combines. And the engines team looks at it in that frame. It was like, okay, we need to support these kinds of machines as well as these kinds of machines.
Okay.
Same thing goes for our controllers and things like that. So.
Very good, thank you. There's somebody behind you. Introduce yourself.
Hi, I'm Daryl Davis. I'm principal of Replicant AD, which is a small business. We do modeling and simulation, system engineering.
Oh.
And so the last 10 years or so, we actually work in the private sector, commercial sector. So this notion of what does the customer want? We do sort of the human-centered design process. So we work with customers, show them prototypes, and then out of those sort of scenarios, the storyboarding type, we get the requirements, but we're also sort of doing this S-curve analysis, trying to predict where the market's going, trends. And so there is a lot of creativity in what we do, and sort of this kind of open atmosphere. The last 3 years, we've actually just started getting into the more government contracting space, and was met with this sort of constraint that, well, here's the requirements that we get. I mean, on the one hand, it is kind of easier, but at the same time, when we want to make suggestions, sometimes there's pushback because of those regulations that we typically didn't have to consider before. And so that's kind of the experience, I mean, hearing a lot of the panelists.
So let me ask you a question. Do you find that when you get through one of your analysis and you do a prototype, you go try it out, do you find that your customer's already moved beyond where you thought he was?
So that's an interesting question. So we try to get early. So one of the principles that we have is human-centered. Another one is just system focused. So we do a prototype, but we include as much as possible all the different interacting elements, external policies, regulations, to try to get a higher fidelity prototype that I want to say is kind of a little bit more than what the customer expected. But then we don't always get it right, but we are open to the kind of changes and feedback that they're dealing with to kind of update that prototype. And so, yeah, I mean, it's a moving target when you're trying to, okay, what does the customer want? You build it, and it's like, oh, it's not quite like that. So we do low fidelity prototyping really to get that rapid feedback. You know, changes are really minimal until we get to something high fidelity.
It's like living with scope creep, you know.
Yeah.
Thank you.
Yeah,
Thank
thanks.
you very much. Somebody else behind you had a question or comment? Yeah, sure.
G'day, Mark Egler, Egler Technology. My company develops technical education and training products. So I virtually have no regulatory constraints on me other than what's imposed by the Australian Taxation Office and the IRS. So what do? I just go and identify the user need, then I look for the gap in the training market. So for instance, I develop systems engineering training products that aren't done in a particular way by other companies around the world. So.
Wow. So that's an unusual application.
Can you accommodate case studies?
I'm sorry, your question, come around this way, or we need to get to a microphone, or say it in such a way that I can repeat it.
Yeah, just, okay.
There you go.
Want the answer, you got this one. Thanks. Yeah, thanks. Based on the conversations that I've heard here today, I just wanted to pass along a case study. I'm working with some other folks in the room right now on a resilient hospital reference model MBSE project. And the first thing that we had to do, of course, is this, it's in the hospital realm, it's in the public health and emergency readiness and emergency preparedness. It's not really with a government agency. And what we used, we actually adopted and adapted a methodology called the Lean Startup Method. If anybody here knows what the Lean Startup Method is, well, the Lean Startup Method is the method that we use to identify the SMEs and to march the SMEs all the way through until they have a good set of capabilities. At that point, we use model-based concept definition and model-based systems engineering, just like everybody else here does. But from the first presentation I saw here today, I noticed what I always notice is over here on the left, on the very left, is a cloud that says something happens and we wind up with a list of capabilities or needs. Well, of course, that's what this model-based systems engineering resilient hospital reference model is. What we do with the Lean Startup Method is we get it right from the start, and we march all of the SMEs and the stakeholders and the customers through a real methodology that they understand, to where they come up with this good set of capabilities. We just left Colorado Springs, where we as systems engineers were in a customer elicitation gold mine, where we had all of these people from the central region of Colorado Health Coalition, and they wanted this resilient hospital reference model, and all of the people in the room, of course, had no idea about MBSE at all. But we helped them understand that they could use the lean startup method to get to a point where they could get this list of capabilities. And the government now, as many here know already, the National Science Foundation, or NSF, has introduced the lean startup method to the government. It's called ICORPS, I-CORPS, and NASA calls it FedTech. So I can pass along that there really is a methodology that we as systems engineers working for regulatory or non-regulatory, this methodology will get you through a process that the stakeholders, you will be able to identify the right stakeholders, you will be able to take these stakeholders through a methodology that they will understand, and you'll get to the point where you have, that was shown on the left part over here, where you'll have the needs and the capabilities, and then you can apply, for example, just for us, our next step is to keep the stakeholders involved, not jumping to SysML, MBSE, but rather using the object process methodology, or OPM, and doing model-based concept definition. So we go from using ICOR and FedTech and the lean startup method, that output gets fed into OpCloud and OpCat, and we get model-based concept definition, and then that output gets fed into a SysML tool or an LML tool like InnoSlate, and away you go. But we really are, and we have for the last 2 years, been using lean startup and model-based concept definition to get this part that's on the left over here, to get that right, and then that makes all the rest of this MBSE work a lot better.
Okay, so there's a book called Lean Startup. I guess that's where they get the theory behind it, behind that conversation.
R-I-E-S, Eric Rees.
Okay.
That's Eric Rees, and as far as the blog is concerned, I would recommend Steve Blank out of Stanford. So Eric Rees is a book we use. Steve Blank is a blog that we use, and also Roman, first name Roman, last name Pichler, P-I-C-H-L-E-R. He's from the Agile project management world, and he's the overlap between lean startup and Agile project management. And then of course, we also borrow from the Agile methodology Scrum, Jeff Sutherland, and so we take the best from Eric Rees, the best from Steve Blank, the best from Roman Pichler, and the best from Jeff Sutherland, and all of that will get you a very nice set of needs and capabilities that you can take through the rest of this process.
Okay, thank you. Any other questions you want to bring to this august body up here? Any other final comments, guys, or you're just exhausted from the day? You got one comment, go ahead.
Finish it up.
It actually ties around a lot of the briefs, and it gets to your question you had about model-based system engineering and people putting PowerPoints into Cameo models or Rhapsody models. And so the impediment is not the tools or the technology. We can do this. The impediment is the culture. And you saw that in many briefs. It's the culture. So using a new tool, but using your old process won't get you the benefits, right? So I actually predate CAD. I was back when they drew stuff on vellum. But when they came up with CAD, it stood for computer-aided drafting, not computer-aided design, because draftsmen, they gave up their vellum and they could now draw in wireframes on a computer model. And the benefit was I could hit delete instead of getting out my eraser and erasing. So that was a little bit of benefit. It made their life a little bit easier, but the data wasn't used downstream, right? We didn't use that in the production. So the same thing applies here. It's like, well, I've always done DODAP views in PowerPoint, so now I have this new MBSE tool. I guess I can take my DODAP views in PowerPoint and put them inside. You're not going to get the benefit from doing that. So that's the culture thing. You have to change the tools. You have to change the process. You have to change the way you use the data. You have to realize that information will be used across the life cycle by multiple stakeholders, as we talked about. And that puts a hump up front in your program because you need to pull those downstream stakeholders involved early. When you do that, as Mark said, you'll fail early, fail often, but you'll build it right. And so you don't have what we call a double hump, which is you're ramping back up for design changes once you're in production. You don't want to do that. That's a real expensive proposition. So it's a culture change to just because you have a new tool, don't do business the way you used to do business. So that's the number one thing is it's culture.
Yeah, absolutely, I'd agree with that. The way I like to put it is the challenge is less rocket science, more brain surgery. It's addressing those cultural impediments that make it difficult to incorporate new ideas, new approaches, and in particular doing so across an enterprise, a much more heterogeneous organization, trying to get their MBSE efforts to get aligned and being able to share information to be able to take greater advantages at a higher level of organization.
So there's your quote for the day, right? Not rocket science, it's brain surgery. Okay. All right, anybody else? Okay, thank you all.